Now you've learned how to differentiate exponentials. Let's have a look at the inverse of exponentials. If you want to click on this, it's just a reminder about your exponentials and your logs, how one is the inverse of the other. And it goes on just to remind you about certain facts of the rules of logs. That's all it is. Okay, you don't necessarily have to go into it and look, because I put the laws of logs here as well. Just to remind you, if they're beside each other and multiply, you can separate them as two separate logs. If it's divide, you can do take. Okay. Right, so let's find the derivative of log. You know that log is the opposite of exponential, the inverse of exponential. So to do this one, what I'm going to do is take the exponential of both sides. Now, we both know that they're the inverse of each other, so they cancel out and you end up with e to the y equals x, or x equals e to the y. There's a star there because you'll see me putting it back in later. The next thing is, you don't always have to find dy by dx. What we're going to do is find the derivative of x in terms of y. So if you know e to the y, dx by dy is e to the y. That is an issue, but if I call it e to the y over 1, what you'll find is we can flip it. So if we invert it, if you like, dy by dx will be 1 over e to the y. Why have I put a star there? Because remember what e to the y is. E to the y is x. So that means your derivative is 1 over x. And the derivative of log is 1 over x. Nice. So let's look at two ways to do log 2x. I will show you this way first because it's my least favourite way, just to finish off with my favourite way. So you could use the rule that when you multiply a and b, you can split it so it's odd. So that could be written as log 2 plus log x. Now, log 2 is simply a number. So when you differentiate, you'll get 0 and you'll get 1 over x using the rule. So that means that you get 1 over x out. So how can we do it a different way? I'm not a fan of separating it if it's a simple function, but if it's complicated, I would separate it. So that can go to 1 over 2x, but watch for the chain rule. The chain rule comes out and then the 2's cancel and you get the same answer. So it's easy to remember the chain rule in this situation. Just do it that way. This one here, 1 over 4x plus 1. And the chain rule comes out as 4, and all you do is bring it together. 1 over sine x, the chain rule brings out cos x. That's cos over sine, which is 1 over tan. It's inverted, remember, which is cot. This one here, the 7's at the front, there's no need to bring it up as a power. All we do is have 7 times what the log is. So the derivative will be 7 over x squared minus 8x plus 3. And then after that, the chain rule will bring out 2x take 8. Then bring it together. I could take it one step further and pull out a multiple of 2. I've not done that here, but I should have, really. Log cos x can be done in 2 ways. So the first way I'm going to do is rewrite cos x as 1 over sine. Then I can separate it. Division means subtract. So log 1, take log sine x. And this is going back to your rules. Log 1 is 0. So then it goes to minus log sine x, which is minus 1 over sine times the derivative chain rule cos. That's minus cos over sine, which goes to minus cos. If it's one function, go to your formula sheet and use that instead. So g dashed x can just be 1 over cos x times the derivative of it. So just use your formula sheet and then you'll see that they cancel down and you get minus cos. Much easier. So if you have something that you know in the formula sheet, don't break it down. Right. This is when I've done this 2 ways to show you that you might find this trickier to differentiate just by doing 1 over and without breaking it up. So here's type 1. So it'd be 1 over x squared sine x, but that has in the chain rule the product rule. So that means that u is x squared and v is sine x. So I find my u and my u dash, my v and my v dash, and it's the product rule, so it's u dash v plus uv dash. So when I go to do this, I have 1 over x squared sine x, and then I have the chain rule come out as that. so it's quite complicated. All I'm going to do is bring everything all upstairs and pull out the common factor of x there. That means that can reduce down a bit, so it's the x's cancel down, so you've still got an x downstairs, and you can leave it like that, but you could also separate it so the sine and the sine cancel down and cos over sine. So you could separate it and have it as 2 over x, and then cos over sine is cot. Okay? It's quite involved. Or, when it's complicated functions, why not use the fact that multiply means add? So if we do this first, this will be 1 over x squared, chain rule 2x, 1 over sine x, chain rule cos x. Two separate derivatives. The x's cancelling, you've got 2 over x and you've got cos x over sine x. And then you've got 2 over x and cos over sine is the same as 1 over tan or cot. This is easier to use when you have complicated functions inside. I would say split it up first, then differentiate. So let's go to another one just to emphasize that point. What about this one here? We can, first of all, look at if we just did 1 over and then use the chain rule. So if I use the method, I'd have, method 1, I went for splitting it up. So if I split it up, I have put x plus 2 minus log x plus 3. And then there'll be 1 over x plus 2. Chain rule just brings out 1 minus 1 over x plus 3. Bring it together as one fraction, multiply the bottoms, cross, cross, and then you can open up and you'll get minus x minus 2, so the x's will cancel down, and you'll get 1 over the 2 brackets. That's nice, okay? Method 2, I've got method 1 still here, so method 2 is what happens if you don't split it up. You could still do it this way, but it's far more detailed. So it will be 1 over the x plus 2, x plus 3. But what about this coming out as the chain rule? You would have to call that u and v and use the quotient rule. So then you would have u dash v minus uv dashed over v squared. The top still goes to 1, which is quite nice. And then after that, you have to realise that that is what's going to go in where the chain rule is. So that's really complicated. The next thing is that means it's 1 times 1 over x plus 2 times x plus 3 squared over x plus 3. The x plus 3 is actually reduced down. I wrote it that way so that you can see, you could either see that they cancel down a little bit there, or what I've done is flipped the fraction, so it's x plus 3 over x plus 2, and then get to that. You could have seen that at that point in there, but that's really quite complicated. So I would suggest when you've got functions within the log to separate them up first, much easier. Okay, now you have to try. So what you've got is Scholar Exercise 12. It's question 52 to 61. I've not put the questions there because I renamed them at one point. And notice here you've got a function in the function. So to treat your log, I would suggest splitting that up using your multiplication rule. Okay, so if you've got log a b, it can be log a plus log b, and it's helping you think about how to do that. Okay, so that's just a hint there for you. Here again, you've got the quotient rule, okay, or you don't have to use the quotient rule and the product rule if you separate it using your log rules first. You'll find all the answers in page 248 and the written solutions are after this slide. So I'm going to stop now, but if you go to your PDF, you'll find it's in page 12, these questions, or you can use the Scholar PDF.